Welcome back to Learning Python in 3 Hours. Today we're beginning a new section on learning specific Python coding patterns. The goal of this is to familiarize yourself with how Python specifically do things like object-oriented programming, handling exceptions, loops, etc. Because we're targeting this course for people who have programming experience but is transitioning into Python, we're going to talk about typical programming topics in the context of implementing in a Pythonic way. In the first video, we're going to talk about how we can implement object-oriented programming the Pythonic way. Secondly, we're going to talk about decorators, which is a Python construct that allows you to supercharge your functions. Number 3, we're talking about context managers, which allows you to wrap up dynamic resources in a very neat way, so you're not leaking any sort of memory or file handler or any other dynamic resource. In this video, we're focused on doing object-oriented programming, or OOP, in Python. In this video, we're going to take a look at 3 different steps on how we can do OOP in Python. Number 1, how everything is a class in Python. Number 2, we look at properties of a class, the keyword self, and the init function. Number 3, we're going to look at static methods, class methods, and inheritance. If we go into the code base that comes with this course, in oop.py, there's a typical example of a class. So this class models a chess game, so it's very, very simplistic and doesn't confine to any OOP principles at all, but the example is simple enough for us to illustrate how OOP is done in Python. Class is a fundamental building block of Python, so it underpins everything that Python does and everything in the Python standard library. The class keyword, as you can see here, is similar to the def keyword that we're already familiar with when we define functions. When we define a class like chess, we use the class keyword, and then whatever follows the class keyword is the name of the class. Every class needs to have an initialize function, where the pattern is define a function that is __init __, a bit like init.py. Here we have initialize function with 2 parameters and a self parameter. So what's with the self parameter to every single definition in the chess class? So the self parameter refers to the instance. Put another way, a method like checkmate defines the instructions for what happens when the game ends and there's a winner. Calling, let's say, game1.checkmate with a winner as player 1 means that we call the checkmate function on the instance game1, and now the instance game1 is referred to by the self parameter. The other thing to note is init. The good practice is to initialize every single variable that the class needs. For example, here I have player 1 and player 2 initialized to whatever player 1 and player 2's names are. Obviously, as the chess object is initialized, there's no winner yet, which is why the winner variable is set to none. But because we have initialized the winner variable, we can then use it later when the checkmate event happens and the checkmate function gets called. So what if you have a function, for example, printing out the fact that the game has started, that doesn't really depend on whether the class is initialized or whether there's an instance of the class. So to do that, what you would do is you use what's called a decorator, something we'll explain later, but what the decorator does is allow you to annotate different functions with additional parameters. Within constructing a class in Python, you can declare something called a static method, where you're simply grouping the following function with the class chess so that logically makes sense, but you're not leveraging any of instant variables or instance functions associated with the same class. For example, if we want to pretty print the progress and initialization of the chess game, we can do something like define print game header, something like this, where it really doesn't matter who are the players and who won. It's always starting a new game of chess. And the way we leverage this is if, let's say, we have a new game, game 1, we can then say game1.print game header, and then it will print out game start. A very nice way for us to group the header printing under the same class, but not force it to rely on any instance-based methods. The other thing is class methods. So class methods are slightly different, where you can define something like print game name, where you say the game's name is chess. And you can imagine that in a different class, the game name, you can still have print game name as a function, but depending on the class, you can say that it's not chess, it's checkers. The reason why you define a class method is the function print game name is associated with the class and can access variables in the class, but is not associated with any of the instances, which is why it's a CLS, not self, to distinguish between the fact that these functions only work when there is an instance involved, and the class method works if the class exists. The last thing we want to touch on is how do we do inheritance. So imagine if you have to talk about supercars and electric cars. So a very common thing you want to do in object-oriented programming is to define a car class, which defines the overall characteristics of a car. For example, with class car, let's say something like with a top speed variable, right? The way you do inheritance is very easy. You define a new class, supercar, and then you inherit car, which is the class we defined above. And we can do something like define name electric car, for example. And for this method, you can return electric car. What this is we've defined the parent class car, and the way you do inheritance is very simple. All you need to do is in the class definition, you give it a parameter, and the parameter is the class that it's inheriting from. And so here we have two classes, supercar and electric car, and obviously supercar's name is returning a string supercar in a human readable form, so it's electric car, but they both share the go function, which simply prints vroom. So that's all there is to it. We've learned today how everything is a class in Python and how we can define new classes. We talked about properties, self and init, and we also talked about static methods, class methods, and inheritance.